Good day, everyone. Welcome back to this YouTube channel. So we are still continuing on differentiation, and in this subtopic, we are doing rate of change. In the rate of change, we consider the introduction to rate of change, then we tackle some examples. Introduction. What is rate? I know you must have been conversant with the word rate. I can say the rate at which we eat, the rate at which you move, the rate at which you work. So when we are talking about rate has to do with time. So I want you to have that one at the back of your mind when you solve this type of question. So what do you look for in rate of change question? Rate of change question can come in diverse of ways. For example, you have x, you have an equation, they are asking you y in respect to x. So since we are dealing with rate, you know that we do y in respect to time and x in respect to time. But there are some questions, they are application questions. Now, you will look for what type of shape is peculiar to that question. It can be a sphere, it can be a circle, it can be any shape. Then what is the properties of that shape? Is it area? Is it perimeter? Is it circumference? Is it volume? That one will determine how you solve this question. So when you see a question, you need to look for all these things as they are paramount to this question. I want to give an illustration. For example, you see a question, they are talking about circular disc. You know, the shape there is circle. And you look further, you know they are talking about area. Now, when you're talking about area, then we need to think of area of a circle. When you're talking about area of a circle, you know that area of a circle is pi r squared. A is equal to pi r squared. Then you can have the A, the R. You know, we have A in respect to time, R, so that we can also have the A dt and also the R dt. Now, combining these three, the A dr will be equal to the A dt divided by the R dt, which will eventually give us the A dr is equal to the A dt multiplied by the T dr. Assuming they are talking about circumference of the circle, C is equal to 2 pi r. So indeed, we talk about the C dr. Then we talk about the C dt, the R dt. So combining these three together, we have the C dr is equal to the C dt multiplied by the T dr. Example 1. A spherical balloon is being inflated at the constant rate of 5 meters cubed per second. At a moment, the radius of the balloon is 4 meters. Find how far the radius of the balloon is increasing at that instant. The first thing you will notice there that they are talking about is spherical balloon. So its sphere is peculiar to this question. And what properties? If you read further, you see they are talking about the rate of 5 meters cubed per second. When you're talking about cube, you know that one has to do with volume. So this question has to do with the volume of a sphere. And if you read the question further, they give us radius. Radius is 4 meters. The question there is the R dt. Now, let us combine it. Volume of a sphere is 4 over 3 pi r cube. So from here, we have the V dr. The V dr is 4 pi r squared, but you differentiate that one. Then the V dr is equal to the V dt multiplied by the R dt. Then when you look at that question, we have 5 meters cubed per second. You know, cube per second. So 5 meters cubed per second is the V dt. Meter cube, which is volume, per second, which is time. That is the V dt. Let us proceed. You remember that I said R is equal to 4. When R is equal to 4, our dv dr will substitute 4 for R in that equation so we get 64 pi. Then the R dt is the question they are asking us. So with the formula, we have the V dr is equal to the V dt multiplied by the T dr. So just plug in all those values. We have 64 pi is equal to 5 multiplied by the T dr. And you see that normally in our question, they can't give you the T dr in your question, give you the T dv or the T dr. What we have is the V dt, the R dt. So when you have is the formula, you know, I used division the other time. So when we change this to, we change the R dt to the T dr. So in this place, the TDR, we will get it from this equation. So our TDR here is equal to 64 pi all over 5. You remember that I said the TDR cannot be mentioned in the question. What we have is the R dt. Therefore, we need to find the reciprocal of this, which will give us 5 over 64 pi. You can leave your answer like this, or you can write it in decimal, which is equal to approximately 0.25 meters per second. Another example. X and y are connected by the equation y is equal to x raised to the power 3 minus 5x squared minus 1. Given that x is increased at a rate of 0.1 unit per second, find the rate of change of y when x is equal to 4. The question here is that the y dt is the question here. You know, the equation is given. Y is equal to x raised to the power 3 minus 5 x squared minus 1. So the y dx is this. So we need the y dt and the x dt. So when x is equal to 4, our dy dx will be equal to this, which is eventually equal to 8. Now, from this question, we have the y dx, the y dt, and the x dt. So when we get all this one, then we're able to find, when we get the values of all, we're able to find what we are being required to find, which is the y dt. Let us proceed. So the y dx is equal to 8, the x dt is 0.1, the y dt we don't know. So the y dt is equal to the y dx is equal to the y dt multiplied by the t dx. So by the time we continue solving that equation, our dy dt is equal to 8 over 10 or 0.8 unit per second. I want you to try to watch this video over and over again for better mastery. Not just conclude that, oh, this topic is so simple. You need to master it and be able to lay your hand on as many questions as possible. Watch it over and over. Actually, on this topic, differentiation, we still continue. And I want you to know that you need to practice as many questions as possible, and always don't forget to subscribe and share with your friends. Thank you and remain blessed. Thank you.